Znaš namestiti to.
Lijevo desno.
Odme samo ga kljuca da ne troši bateriju.
Može i kasnije sam...
Spustiš i vidiš.
Što ste se dogovorili ta završena računa dali svoj napad? Hoće onda sami ili... Kako smo dogovorili? Desno. name is Angela, and I'm a junior project manager here in Locastic. I want to welcome you on this first meetup in 2019. So as many of you know, Tinel means living room in Croatian language, and that's where the name of this Tinel meetup comes from. Last year we had 12 Tinel meetups, and as you can see, one per month. And here you can see some of the topics we have touched upon. So, do you want to hear anything about future oncoming Tinel meetups? I suppose you do. So here are some topics that will be on future Tinel meetups, and I hope that you will like it and join us again on our meetups. So all of this wouldn't be possible without the help of our partners. And here I want to thank to Marvi for accommodation for our guests. Pauline, we hope that you will love it. Barba, thank you for awesome local craft beer. I see that some of you already drink it, so it's awesome, I suppose. And Biberon Cakes, thank you for delicious pizza and cake. Split Tech City, thank you for streaming so others can watch this meetup as well. Uber, thank you for free transport for our attendees. You can use code TINELMeetup01. It is written on the wall behind you as well. Netocracia, thank you for your support in promoting this meetup. So we have gathered here to hear some interesting and helpful advice regarding Git optimal usage, right? Our today's meetup host is Pauline Vos. She is a software engineer and Scrum Master, currently employed in Werkspot in Amsterdam. And she will now have a talk, and I hope that you all will like it. Enjoy the meetup. Thank you. Set up the screen. Yeah.
We don't have a USB, so this won't work.
Hey, where's the screen going?
Should appear.
Oh wait, maybe I can do it this way. Interesting. Or just maybe off.
There it is.
Ah, okay.
Just showed up. Yeah.
Oh, there's a code. Oh. 267.
The big unveiling.
Is it too far to draw? Is it mirror? All right, thank you. I'll try not to go in front of the sides too much, so put down my beer and grab it again. Welcome everyone. Thank you for having me. First of all, thank Tinel Meetup for having me. I'm really flattered to have been invited here. And I hope you're all ready to get legit. Who here is actually using Git already? Okay, thank God. Otherwise, it's kind of useless information. First of all, a little bit about me, just a little short introduction. So, as was already mentioned, I'm Pauline. I'm a software engineer at Werkspot in Amsterdam. And Werkspot is like a kind of a marketplace for consumers to find service professionals for like if they need like a house renovation or a gardening job or whatever. They go on there and they find someone to do their job. And we're located in Amsterdam, but we have branches in Italy and France as well. That's more about my job than about me, but there you go. That's a short intro. Oh, I actually do have a side about work. Should have shown that. Anyway, is this you when trying to work with Git? Can everyone see? Or because I know this has been me plenty of times, especially when I first started out using Git. Basically got stuck rebasing for hours on end, and it was terrible. And the stuff I'm going to tell you today is going to make you be more like this, which is the optimal, I actually quite like the light saw. It's the optimal hacker zone that developers like to be in, you know, when your fingers, when it feels like you're playing the piano as opposed to programming, and you're just flying through it. And the way I achieved this zone was through atomic commits. Has anyone already heard of atomic commits? Okay, a few tentative nods and a hand up. So if you're not familiar with it, it's basically what it sounds like. If you think of the word atomic, and what atomic means, it's something that's so small that you can't divide it, otherwise it explodes. Commits won't explode. But atomic commits are commits that are really small and you can't divide them up any further. And basically I feel like they have three features. So a commit is atomic when it has these three traits. First of all, they're a single irreducible unit. So that means that each commit pertains to one feature or fixer and one part of the code, not several parts of the code. To demonstrate, I'll show you the commit on the left. If you read that, it'll say build signup feature refactored mailer class. This commit holds the entire signup feature, controller, repositories, templates, etc. As I was doing that, I saw the mailer class needed some refactoring, so I went in and did that too. And that's all part of the same commit, but it's all different things, right? So for an commit to be atomic, it should be split up in all of those things separately. So on the right, you'll see there's one commit for creating the endpoint. Well, we'll start at the bottom, actually, because that's chronologically how it would have gone. So the first commit is refactoring the mailer class. Then the second one is creating the user entity and the repositories for it, so all the persistent stuff. And then the last commit is the endpoint finally. So that's kind of what I mean by single irreducible unit. Then the second thing is that everything works. So the build doesn't break, the tests are all green, everything's actually covered because it's really easy to make the tests go green if there's barely any tests. Yeah, your application basically works as expected. So, and that's not at the end of your PR, that's on every commit. And then third, the commit needs to be really clear and concise. So the message and the description need to really clearly convey what that commit is about. And that automatic PR becomes a lot easier when you hold to the first rule of the single irreducible unit. Because you don't have commits that go, did this, and that. You just have, did this, clear and concise. Now these things, that's essentially what make up atomic commits. So that sounds really simple, and it is, but it's going to help you with a lot of things, and we're going to go through all of those things. The first of which is keeping your sanity. That's a big one. So imagine the scenario where there's a story branch, and you branched off from that to work on a task. And your coworker, your teammate, is working on another task on the same story. So you both have the same story branch as a base branch. But they have now created a PR, it's been approved, and they've merged it into the story branch. There's now new changes on the story branch that you need to sync up with. So you can, for instance, you can fetch and pull all those changes into your branch. Who would do that? Okay, this question never, well, sometimes it doesn't get any response, and I don't believe it. So there's two options. So there's pulling the changes in and creating a merge commit, or rebasing. Who would rebase? That's about the same amount of, there was another nod from the same person who heard of atomic commits. So just to reiterate on these concepts, or if you're not familiar with them, just to explain it. So a merge does this. You have your base branch, that's a branch in yellow. There's a few commits there. And then you have the branch that branches off from it, and there's a few commits there. Now the base branch has changed, and then when you pull, it merges everything, it checks the delta and merges everything, and if there's conflicts, you fix them, and then it creates a new commit. So that's pretty simple. You just check if everything's okay, and then you sync it up, and there you go, that's a commit. But the thing is, one, that commit is not atomic, because there's changes from all over the place, basically, that are nothing to do with each other, and they've kind of just been smushed together. and you can't make that commit descriptive because you have no idea what's changed in that commit. There haven't really been any particular changes except for the fact that you compare 2 points in time and put it together. Now rebase. So same start situation. You have your base branch, and then you have the branch that you branched off with. And instead of, when you compare the changes, instead of smushing the changes together and making one new commit, a rebase will, it will act as if you just checked out your branch from that branch. So it'll just, it'll rebase onto the base branch. And what it does under the hood is it replays all the commits, and it compares commit by commit what those changes were at that point in time. And then by replaying all those commits and comparing it, it will rewrite history. So you get to solve merge conflicts, if there is any, and then just rewrite the commit that you already had to compare with the changes on the base branch, basically. And then it will go to the next commit and the next commit and do the same. And that way, there's no new merge commit. You just keep overwriting the commits that were already there. And so your history is kept intact. And all your messages still make sense, and all the changes are still where they're supposed to be. Now, when you're not using atomic commits, and we'll get back into like why this happens, but when you're not using atomic commits, and you try to rebase, you're going to end up with this. You're going to have a lot of conflicts that you keep having to do over and over and over again. You keep having to resolve them over and over and over again. And again, we'll get back to that in a second, why that is. But that leads to really frustrated developers, and it'll result in history like this. I don't know if you've ever heard of commit logs from last night. This is a website that basically searches public repositories for a random profanity and creates a feed. And so you end up with pretty funny results. There's a QR code if you want to check it out. Anytime there's a QR code, it means I think it's worth checking out later. Obviously, this is just for funsies, but there's some resources there, so if you want to take a picture. Then
but you printed that on the sheet form.
Well, I'm not going to mention all of them. Yeah, so there's also a few other ones. I'm not going to go through the whole list, but it's not just shit. But it's clearly a lot of shit. So this might be funny for entertainment purposes, but obviously you don't want this in your open source projects history or your corporate applications history. So that brings me to the next thing that atomic commits are good for, and that is history. So when people start out using Git, and I'm the same, most people will kind of use it as a save point. Because that's kind of how it feels. Like when you're typing, you're used to software having save points, like video games. You make some progress, and then you think like, oh, I have to find a save point, because otherwise if I die, I lose all my progress. Or like Word documents, you'll type, and you're afraid that like, oh, I've already been typing for half an hour, so I'm going to save this so that when my Word crashes, I don't lose all the progress. So it makes sense that you would think of Git in the same way. You code, you commit something, you push it, and you're done. But then you end up, to go back to the having to resolve the same conflicts over and over again, that's why that happens. Because if you're using it as like a chronological timeline with save points, if you do the rebase and it replays all your commits, you've been meddling in the same part of the code on every commit. So every time you compare on your new commits, it's going to have the same conflicts, the same exact conflicts, because you've touched that same part of the code. So rebasing doesn't work if you use it that way. And also what happens to your history is basically this. So start from the bottom here. You have a commit that says fix small bug, because there was a bug and you had to fix it, so you went in and fixed it. But then you realized after you created the PR, you were like, oh shit, actually that breaks something else. So then you fix the fix, but you've already committed your code, so you're like, okay, I guess I'll create a new commit. Then on your PR, someone leaves comments, so then you address those comments, and you push it. And then so on and so on and so on, when at the end of the day, what you were trying to do is to just fix the bug. So ideally, you just have that commit, because that's the point in time you want to know what happened. You want to know, this point in time, I fixed the bug. All that other stuff, like address comments, fix the fix. First of all, your application is broken on each of these steps, or almost each of these steps. And second of all, outside of the scope of your PR, if people are looking at this history, outside of the PR, they're not going to know what happened, because they don't know that all of those commits actually have to do with fixing the bug. So ideally you want all those changes in that one commit, because that was your end goal. That brings me to the first handy command that Git has that can do that, and that's git commit -men, or -am for short. So with that, you can basically take any changes and just add them to the last commit that you had. So you just like rewrite the last commit that you had, and you just keep doing that. So that's one way it could have been resolved. Just quickly demo that. So you have these two commits, and we're just going to make a change, and then you'll see the changes there unstaged. Then you use git add to stage them, and then you do git commit -men. And it will open a little dialog, and it'll let you change the message and description. And then you just save that text file. It's just a text file, so it'll open in like whatever text editor you use, like Vim or Nano or whatever you use. And then that's been added to your last commit, and your last commit has been rewritten. Now, under the hood, this creates it replaces your old commit. So it feels like it's rewriting your commit or changing your commit, but it's actually creating a new commit with a different hash. Which means that if you try to push it to origin, your origin will think it doesn't belong there, so it will get rejected. So you're going to have to force push when you rewrite commits, which sounds really scary, but it's actually not that scary. But we'll get back to that. So what if you have a situation where it's not just the last commit that you have to change, but a few commits back, or several commits that you want to change? You can't use amend, because amend only amends your last commit. Now, we already talked about rebasing, but you can also use an interactive option on your rebase. And so it does the same, it replays your commits, but the interactive option gives you a bit more control over how it replays. And you don't have to do that onto a different branch. You can actually rebase onto your own branch. And so if you use git rebase -i, that's the -i is the interactive option, and then head tilde, and then however many commits you want to go back, you're rebasing onto your own branch. So you're replaying all of those commits on your own branch. And the interactive option will give you another dialog like this. So like I said, it just gives you a little bit more control. You'll see at the top, you'll see those 4 commits that I wanted to go back. And you'll notice that there's a pick in front of it. Now that pick just means, if you keep it that way, it just means replay and do nothing with it. But you can replace that pick with all the commands that are listed under there. So we'll just quickly go through what all of them mean. We just covered pick already. Then there's R for reword. So you can replace pick with the whole word or just the one letter that it represents. So you can replace it by R or reword, and that's just changing the message. Then E for edit. That basically just checks it out as if it was your latest commit. And then you can do all your changes and amend. That basically gives you the most control. Then you have squash, that smushes the commit before into the one, the commit after into the one before. Fix up does the same, except it's quite a lot faster, because squash will still open the message screen and let you change everything. Fix up just smushes it and then automatically just uses the message that of the first commit. Then X is actually pretty interesting, because with X you can run a command, like any shell command, anything you like, over that commit. So you can, for instance, say X and then linting. So you can automatically run the linting on that commit, or you can run your unit tests on that commit to see if that commit doesn't break any tests, which you need to know if you want your commits to be atomic. And then lastly, you have drop, and that's just drop the entire commit, get rid of all the changes that I made in that commit. So I'm not going to demo all of them, obviously, because that's quite a lot. But here's edit. So there's some changes there. I'm going to stash them for later. And then I'm going to go into my interactive rebase, and I'm going to go 5 commits back. And I'm going to change the pick in the first and the 4th commit to edit. I'm going to write the file, and it checks out the first commit. Then I'm going to apply my stash, so my changes are back. And then I can stage those changes, and when I do git rebase -- continue, it'll act as if I wanted to amend that commit. So it'll let you change the message and stuff again. Then it goes through to the 4th commit, because I said I wanted to edit that. I'm just going to make some changes there. And basically just do the same thing there. And then git rebase -- continue. It amends that commit. And then so you've applied all these changes, but you've kept your history the way it should be. So the next thing it's going to help you with is code review. What I did when I started developing was I looked at the, so in GitLab is similar, but so in GitHub I would just go to the files changed tab because I wanted to know what changed. So then you go files changed, makes sense, right? But then you'll see there's 30 files, and they're in no particular order, and there's no context to the changes except for the PR description. So that's a lot to handle, and you're going through these 30 files, and you keep losing your concentration, and you don't really know what you're looking at, and you have to keep going back. So it's not great for productivity, and it's also not great for the quality of your review, because if you can't really see what you're reviewing, and you keep losing focus, then your review isn't going to be very, very good. So with atomic commits, you can actually review commit by commit. And the reason you can't do that if you're not using atomic commits is because, again, you're using these save points. So if you start reviewing the first commit, for instance, and you comment something, and then you head over to the second commit, and then you see that what you said in the comment was already changed, your comment was kind of useless. So it doesn't make sense to review commit by commit because you're not commenting on the most up-to-date information in those separate commits. And with atomic commits, it pertains to one fix or feature. So you know exactly what set of changes you're looking at, what part of the code you're looking at, and so you can just go through them one by one. And again, you have the context. So for each chunk of changes, instead of having those 30 files, you have a little title and a little description, so you know exactly what you're looking at. And so your review is going to get better, and you're also kind of chunking the data up so you don't get that information overload. Now, you'll see that this message has a title and a description. This is, there's no real standard for this, for like how you should format your messages. Some teams like to put their issue tracker number in front of the title. Some people like to use Gitmoji, which is basically like you all have like a legend of, okay, a little heart emoji means it's a feature, a little bug emoji means it's a bug, and so everyone can see straight away what that commit is about. So this is the standard that we use. No Gitmoji, no issue tracker stuff. But there's some general guidelines that are widely adopted that we're just going to go through. And again, you'll see a QR code, and that's because these rules are mentioned in this article. And aside from these commit message rules, there's a lot of like best practice, like tips and tricks, things that are not going to be covered in this talk. So it's quite good to take a look at later. So the first guideline is to separate the subject from the body with a blank line. One, because it makes it more readable, and also for another reason that I'll show you in a second. Then limit the subject line to 50 characters. It just makes it a bit more readable, but also someone recently told me that this is also a legacy thing from back in the day where there was like a grid with a certain amount of characters, and it's just kept that way throughout the ages. But yeah, it's just a guideline, just to not have your subject line too long. Capitalize the subject line. Don't end the subject line with a period. Not really sure about that one. I never ended with a period just because it saves characters, but I guess it gives you some consistency. I'm not sure about this one, to be honest, but I still use it. Use the imperative mood in the subject line. To me, this is an important one. So by the imperative mood, I mean instead of saying fixed bug, you say fixed bug. You don't say creates blah 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 or adds blah blah blah, added blah blah blah. No, add, create, because it's more direct and it's more to the point and it reads a lot cleaner. And it saves characters again. Wrap the body at 72 characters. That apparently also has one of those legacy reasons I mentioned before, but actually if you don't have so the 72 seems arbitrary now, but if you don't have a line wrapping rule here, and you just have like a really long description, also when you're reviewing it, it gets super annoying because I've had this a lot actually, you have to actually horizontally scroll all the way to the end of the line and then all the way back, because it doesn't wrap that in GitHub or GitLab. So if you just have the 72 characters, it's a nice little, and you can really easily read it. Yeah, I do a lot of sound effects. I don't know if you've noticed. It's like one of my things, I don't know why. And this is another really big one. So you have the subject line, and then you have the body, and in the body you can elaborate a bit more. So the subject line is really concise and to the point, so you can just at one glance see what it does, and you can use the body to elaborate onto generally good practices to explain first what you did and then why you did it. So just an example of the subject line and the blank line in between. I'll give you an example. The top commit on the left says addresses comments about the test not passing and class being too bloated. So first of all, it's not doing one thing, that commit, and also it's not one line, that subject line, so it doesn't really read very well. And then to the right, you see that subject line with the blank line and the description under it. Now, this has other implications apart from it being more readable. Also, when you git log, when you use git log, you see your history including the description. But if you use git log --1 line, which I actually use a lot, you only get the subject line. So if you're really looking for one particular thing, or just a really quick overview of what changes have been made recently, then that is really good. And that doesn't work with that other commit message. If you go back and the subject line spans 2 lines, then that one line is not going to work, obviously. Now you might think all these rules for like wrapping the body at 72 characters and the subject line being 50 characters, how are you going to manage that if you have to like count them manually? Well, of course you don't have to, with some nifty configuration. This is just a gist that I use on any new machine. It's like one of the first things I get. So some bash profile stuff that will automatically, it has git auto completion, so you can just tab through all the commands so you don't have to type them all out, and also branch names, which is great. It does some color stuff to your terminal, and it wraps the body automatically, and it tells you when your subject line is too long, so that's quite nice. This is provided by Luis Cabucci, really good resource of just endless knowledge. If you're interested, check out his other stuff. Now, some quick wins, aside from the general stuff that atomic commits will improve your life with. Some other quick wins, like as bonus points for atomic commits, that you can now start doing once you implement them. The first one is you can cherry pick really easily. And I don't know, who's not familiar with cherry picking or the concept of cherry picking? Okay, so cherry picking is basically you take any commit from a different branch or even a different fork of the same repo, and you take that commit and you put it onto your own branch. Now, if you don't have an atomic commit, you're going to have loads of different changes, like changes for instance, if you need one feature and it's spread out over 4 commits, you're going to have to cherry pick all those 4 commits instead of just having the one. It's going to be really unstable. You're going to have all these different changes that you don't need. Now with atomic commits, you can just have those sets of changes and put them on your own branch, which is really great if you and your teammate, for instance, are working on the same story branch and you're dependent on their changes. And to continue your work, you just need a class that they've created or something. And then because they kept their commits atomic, you can just take that commit that you need and put it in, and you don't have to rebase onto the entire branch. So that's really nice. Don't do this too much though. If you're gonna cherry pick like 6 commits at a time, you should probably just rebase. Just to show you how that works, let's say that's the commit hash of the one that I want to have. I check out my own branch again. I see there's 2 commits here, and then I go git cherry dash pick, and then paste the commit hash. And then when I do git log, you'll see that there's an extra commit there, so it'll just put it at the end of your branch there. Next quick win is dropping stuff really easily. So if you're using Git as a save point, you can't just go into one commit and just drop those changes, because those changes are dependent on your previous changes and the other way around. So to give you a really quick example, because this is kind of abstract, one way I like to use this is, well, that's a situation I think that a lot of people have or run into, is they start building something and then they see that something, some class or whatever, is a mess, so they want to refactor it. So in my situation, I was building a feature and I had to touch this class that wasn't PHP 7 compliant yet, so I started doing all the, I don't know if anyone's PHP here, but they added strong typing in the new version of PHP, so I started PHP 7 proofing that class. But I was like, you know what, I'm going to make that a separate commit. And then when I pushed my code and created my PR, CI failed, because it turned out from the acceptance test and the integration test that in some places we were actually passing the wrong data type. So then if you all of a sudden start strongly typing stuff, everything's going to break. So I was like, okay, this does obviously at some point need to be refactored, but right now it's breaking stuff, so I'm just going to drop that commit. And because it was separate from all the other work that I did, I could just go to that commit and just completely delete it. Whereas if it was intertwined with all the other changes that I was doing, I would have had to go back into the file and manually undo all the changes that I had done. So that's really time consuming. So pretty easy. I'll just show you, you saw before that drop was one of the commands in the interactive rebase, but I'm not actually sure why, because there's an even more straightforward way to do it. So git log, you'll see refactored some class. That's the commit I want to drop. Then I'm gonna, can everyone see the actual commands? Okay. Then I'm gonna go into my interactive rebase and just delete the line, so I don't even have to replace pick by drop. And write the file, and then the commit is gone, so you can just delete the line. Next thing, this is always a big spooky one, is git bisect. Who has heard of git bisect? Couple hands who's used git bisect? Yeah, see, that's why I say it's a really scary one, because it's one of those things where, like, people hear about it, like, ooh, git bisect is a super handy, advanced feature, whatever, and then nobody actually, because it's kind of a big hurdle to get over, but it's actually super handy. So you might wonder why I put an egg emoji for git bisect. That's because bisect stands for binary search. And I find that binary search is really easily explained with a bunch of eggs and a building. So let's say you have a building, and it's X stories tall. And you want to know what the first story is where you break, where you drop an egg and it breaks. So let's say like the first 10 floors you drop an egg. This is not a realistic situation. Just a side note. The first 10 stories, it doesn't break, and then the 11th, you want to know that it was the 11th is the first one and it's going to break. Now, one way to go about it is to just start at the bottom, drop the egg, it doesn't break. Go up a level, drop the egg, it doesn't break. Go up, go up, go up, until finally it does break. Now, if you have a building with like 50 stories, you might be super lucky, which again, realistically, probably true, but hypothetically, you have 50 stories, and it could be any one of these stories. So you might have to go up, 50 stories before you get it right. What you could do is use a binary search method, which means that you start in the middle, and then you see that it breaks there. Then you know that the first point it's going to break is between there and the bottom. So you go to the middle of that. You know that it doesn't break there, so then you go to the middle of that. And so it takes you a lot less tries to figure out, especially when it's a really tall building, when it's like 50 stories. It's going to take you probably, it's probability, but probably a lot less time. And you can do the same thing with your application. If, for instance, you noticed that some button on your platform is now weird for whatever reason, and you want to know what changed and why it's now weird, you can go back in time, because you know that a month ago it was still working fine. So you take a commit all the way a month ago, and you say, okay, that one was good. Now let's see if the one in the middle was good, and then in the middle, and then in the middle, and then you'll find out the commit that broke the button, basically. So just quickly demonstrate. This one is a bit quick, and it's a little bit more intense than the other one, so we might have to view it twice, but spacebar. So you start your git bisect. Git bisect starts. Then you mark the commit hash that you know is good with good. Then here I take the last commit hash because I know that one is bad. So I go git bisect bad, that commit hash. Then it'll check out the commit in the middle of that. You run your tests or you do whatever, you refresh the page or whatever. You say, okay, that one's good. You go git bisect good. Then it'll check out the one in the middle. And then you just keep marking, this one's good, this one's bad. And then at the end of the iterations, it'll say, oh, it's this one. And then you go out of your bisect by saying git bisect reset, and it'll just like spit out the commit hash that broke everything. So, does anyone want to see it again? Or is that fine? Okay, so this is one to really try out for yourself to see what kind of value it has. So a really good way to do this is to just take your application, go in the history, go somewhere in your history, somewhere random, and just break a test, and then go back to your head and run bisect, and then you'll really see, like, as it's checking out the commits, and then you run the tests, you'll see, okay, the tests are failing here, I'm going to mark it as bad. And then, so that's a really good way to practice it, and then you kind of understand the concept a little bit better. So, just to remove some skepticism before we go to like general Q&A time, Luis, the person who made that gist, came into our company and basically preached this gospel to us, which is why I'm telling it to you now. But I was really skeptical because obviously you're like, okay, this is a kind of a mind shift and it will affect the way I work a lot. Like, doesn't it take a lot of time to keep your history clean? So before we go to the general question and answer, I'd like to just ask the same questions that I asked Luis and already preemptively answer them. So one question was, how do I call people out on mistakes? Because you're rewriting history, and like in that example from before where you fixed the bug and then you actually broke something while trying to fix the bug, obviously if you keep amending that commit, that goes away. You can't tell that someone's done that. But then you have to kind of wonder, what is the purpose of source control here? Because pointing fingers at, and that sounds really negative, but blaming people for mistakes isn't really the point. Like, the point of source control is to control your source. So the most important thing about source control is that you have your history, you know what changed when, you know that everything's in a stable state, you know that you can go back to any time in history and things won't break. Like, for instance, if some feature is launched or whatever and you need to be able to revert it or whatever, you should be able to easily do that. And I think that's a much bigger advantage over on a PR going, hey, but you broke it there. Like, there's not really any point in doing that. So this is a big one. How will this affect my flow? Because like I said, like, it takes long to clean up your history, and if you're using those save points, it's just save, and you can just keep going without really thinking about it. And especially on, say, like a Friday night or whatever, you just done a bunch of code, and then you want to go grab a beer, or you want to go home. So you don't really want to spend time cleaning up all your commits. And that's perfectly fine. You can still work that way. But there's a difference you discern between private branches and public branches. So your public branches have to be clean. Your public branches are branches like master and like your dev branch or acceptance branch or whatever public branches you use that everyone else is working on. Your private branches, the branch that you've created yourself and you're working on by yourself, as long as you're still the only one that's working on that branch, you can make it as messy as you want, as long as at some point you clean it up before it gets merged into the public branches. So I actually do this every day. Every day before I go home, I just like create a messy commit, and then the next morning I'll clean it up after. It's actually quite easy. So I'll just show you what my usual ritual is in the morning. So you'll see a massive commit for a day's work there at the top, and then you git reset your head. So that just resets the latest commit as if I've never made it, and I see a bunch of changes there. There's one called handler, there's a couple called bug fix. Like if you see the history, you see, wait, let me just go back and do that again, because it's going a little bit fast. Yeah, so you have your commit. Then you reset it and just look at the changes. There's a bunch of changes, okay? And then you go into your history and you see, oh, what commits do I already have? You see you built some handler, added feature X, fixed horrible bug. So then you know that the handler change goes into that commit. So you just amend it to that commit. Then you see bug fix. So you know that has to do with the bug fix commit. And two changes that have to do with feature X. So you just add the two feature X file changes, and so you'll see they're staged here, and then you'll just create a temporary commit, just really quick. Just git commit -m feature X, so you know what you're talking about. Then what remains is the bug fix, so you add that, and then you create a temporary commit for that, and then you can go into your interactive rebase, and you'll see those temporary commits there. And then you can cut and paste the commits after the commits that they belong to. And if you replace pick by F for fix up, it'll just squash those things into the commit they belong to. And it rewrites history, and then you're done. So that really only takes like 15 seconds to do, and then your whole history is clean. So you might prefer that as opposed to constantly keeping track of your clean history, and that's what I do all the time. So, to come back to the force pushing. Isn't force pushing scary? Yes, if your branches aren't protected. So, at a place that I was working at before, there was actually a girl. She's from Split, actually. Funny. I always take this example, but she's actually from here. She was once working on some feature or whatever, and then she committed and she force pushed. And then she realized I didn't actually branch off from master. And so she overrode master with what she had. So it was, chaos. Luckily, we had a recent copy of master, so we could just replace that. But like, if you think about it, why was she even able to do that? It's not that she didn't understand what was going on. It's not that she was dumb. It was just she just forgot to check out a branch. And developers are human, and it's really easy for people to blame other people for instance, dropping a whole table from the production database or overriding master. But I'm a big believer in like protect your devs. Like, don't give them write access to the database, production database. Don't give them the right to force push to master, because there's no need for them to force push to master. So just keep your public branches protected, and force pushing is fine, because you're only force pushing onto your own branch. If you're worried that you're overriding your own changes, and you're worried for some reason that your own stuff will get lost, you can always just check out a copy of your branch for safekeeping. That concludes those questions. If you have any more questions, please go ahead. Thanks. Yeah?
I have a question about this whole workflow. Basically cleaning up your personal branches. I kind of don't see the point. The way we work is basically on GitHub. Now you have like a squash and merge button that automatically like squashes all the commits into one big commit, and then you just merge it into the master.
Yeah, you can do that, but if you go back to the, and a lot of people do, but that's also what version tagging is for. So if you want different, because you're probably using this as sort of a version thing.
I mean, apart from like making it easier for other devs to do VR reviews or something, I don't know. Basically,
not just that.
One big commit with,
Not just that. Say you have a PR with like 8 commits, right? And you've been working on this feature super long, and then you merge it to master, and something in one commit is screwed up. Now you have to revert that entire feature just to get rid of that one commit. Whereas if it was all small chunks, you could have just reverted that one feature, one commit, and so that's one thing.
I mean, I understand the point, but to me, it's more important to just preserve what, every event that occurred on the master branch, then override it and make it clean, because it tells a true story about how development happened, and if you're looking back, you can see, if something got messed up, which commit was it, which PR was it, just like preserve everything, and then, I don't care, nobody's going to be looking at how clean.
Okay, so it's funny you say preserve everything, because by squashing and merging, you're actually not preserving those commits. First of all. Second of all, you're not rewriting commits on master, ever. You're only merging into master, ever. And third, if you want the deliverables, because that's essentially what you want, right? You want like, oh, at this point in time, we release that feature. At that point in time, but that is what version tagging is for. So then you have the versions, and you can generate a change log for that. So I hope that, I'm not trying to like convince you that my way is the best way or whatever, but like, yeah, just some, maybe a little bit.
I prefer your way with merging all the commits. This trashing is actually started from open source community because of the numbers of contribution. Because if you merge like 10 commits, you get 10 plus on your commits. So basically on some small PR, you can fake it and be like top 10 contributors. So people start to squash everything, like have one feature to one pull request with one commit, but I don't think that's a good way, because it's much easier to debug later and see what's happening in a huge pull request, like in one project that we are using, which is open source. The merge request was started in 2016, so without atomic commits, it was impossible to track what's happened in the last 2 years. So if you squash that to one commit, it's not, I don't think it's a good practice. And the number of commits and something like that is just statistics, so I think it's so much more.
Yeah, because if it's about that, then version tagging is your thing, right? Like, but yeah, that's, I mean, I agree. But at the end of the day, it's also kind of like what works for you. I just don't see necessarily those reasons as the be-all, end-all reasons to use squash merge, just because of the version tagging is already a thing, and yeah, all that stuff.
How do you sell this to the teams? For example, I work with a team who refuse even to rebase their own feature. So basically what they do is they merge masters. They have like a long living personal branches. They merge into the master into their own living branch and create PR. Then when the PR is merged, there are more commits to master. They again merge to their PR. So like after a year, the guy sends me a PR with like 78 commits.
Yeah. See,
and
that's
it's a one-line change.
like,
so how do I convince them to rebase it?
So obviously, I'm not like a master debater, so at the end of the day, the persuasion is your part, obviously, but I do think that a really, really big thing is the keeping your sanity thing, because the situation that you describe where you keep pulling in changes from master, and then especially with long-living branches, then a day later you have to do it again, and then a day later. You keep getting these merge commits, and then you keep having to constantly solve merge conflicts, and that's exactly how I was that monkey with the computer who just gave up, because you just spend so much time fixing merge conflicts. It's ridiculous. Whereas with atomic commits, you don't, because you're not. Yeah.
So their argument is just look at the atomic. Ignore
Yeah.
those 130.
Maybe you should time how long they spend just solving merge conflicts. That might be a convincing thing. Otherwise, I don't know. Ask a salesperson. I don't know. That stuff.
I have a situation where on a pretty great project we have a few versions that are in productions. So I have a different branch for each of those versions.
Wait, what? You have separate versions on production?
Yes, because the customer, if he wants to upgrade to newer version, he has to pay. So some customers
like
are
that.
using older versions and so on. And now, of course, if I fix something on the lowest version, that change propagates to the bigger versions. And that all wasn't the problem until in the last version, we completely changed the navigation, the folder structure, everything. So now the same file is in a different folder. So if we fix a bug on the older version and we want to merge or shall pick that commit the newer version, now it's not in the same folder anymore.
Yeah.
So is it possible to somehow track, to say to Git that this folder is now called this way?
Well, I don't really fully understand the situation here. But I feel like you're using different folders as different versions, right?
No. What I mean, in the newest version, the folder structure changed. The files stay the same. Controllers and templates stay the same, but the navigation changed, so did the folder structure. So now the same controller for the same feature is now in a folder that just has a different name.
Oh, right, but if you're...
So now when I fix something in that same controller, older version, and I want to apply that fix on the newer version, it's not in the same folder anymore. It's the same file,
Okay.
It's identical, but it's not in the same folder.
Yeah, okay, then it sounds like you just have to check out to the point in time at which that version is. So, because it sounds like you're going just on your head and editing that, and obviously it's not in the same place there, but if you go back in time and check out that, then the folder structure is still going to be in the old situation. Like, it's not going to... Yeah, this is really... Maybe we should look at it after, because
I can show
like,
you
yeah.
I have one solution that was used in a previous company I worked at. A friend of mine, he had different branches for different versions, and he never merged them into master or that branch or anything. Those were just like the tips,
Yeah, that could work.
Whenever you change something, you have to apply it to different branches. So if you're making totally different versions, those are totally different commits, everything. It's like applying the same fix in a few different places.
Yes,
but
there's another complication.
Yeah, and then you get
there's another complication here, and that is that the client actually uses SVN for versioning. So I use Git only for myself. And then
I can see how that would be a problem.
When I change anything, I have to make a new build in each version separately and copy everything in there.
Okay, now it's just gone out of scope. I was going to say out of scope here.
So that's why I have versions in different branches. And because some users use this version.
Yeah, so that's a bigger problem than Git usage, I think.
It's not really a typical situation yet, but anyway, the question is, if I want to merge some change into the other branch, but now the folder name is changed, is it possible to do?
Not really. It really depends on the situation. I would really have to see it, but we can talk after. Anything else, or is that it? That's it. Okay. Thank you.